Have you ever wondered about the mystery of rogue waves? Those towering giants of the sea that have populated the mythology and folklore of sailors and coastal areas for centuries? These waves, also known as freak waves, monster waves, or more scientifically, rogue waves, have been the subjects of many a tall tale. But it wasn't until the first day of 1995 that these waves shifted from the realm of maritime legend into the focus of scientific scrutiny. That's when a colossal 26-meter wave slammed into the Norwegian Draupner oil platform in the North Sea, providing the first measured evidence of these oceanic behemoths. This extraordinary event sparked a curiosity that rippled through the scientific community, prompting a wave of research into these enigmatic and powerful forces of nature. So it was in 1995 that the scientific exploration into the mystery of rogue waves truly began. The rogue wave that struck the Draupner oil platform in 1995 was the first of its kind to be measured, providing scientific evidence that these abnormal ocean waves truly existed. This monumental event took place in the North Sea, sparking curiosity and intrigue amongst the scientific community. This rogue wave, towering at an astonishing 26 meters, was significantly higher than the surrounding waves. These giant waves, also known as rogue waves, are a rare sight, but their extreme heights pose a serious threat to ships and coastal infrastructure. Rogue waves are among the most powerful natural forces on Earth. They are the titans of the sea, standing tall and powerful amidst the vast ocean. Imagine a wall of water that suddenly appears out of nowhere, dwarfing all the other waves around it. That's the gargantuan magnitude we're talking about when we refer to rogue waves. Interestingly, global trends reveal that ocean winds are likely to become stronger due to climate change, suggesting that these waves could become even more powerful. The potential increase in their size and frequency could lead to more severe impacts on maritime activities and coastal communities. Prior to the Draupner incident, the existence of rogue waves was largely part of maritime folklore and tales of the sea. Sailors would recount stories of monstrous waves appearing from thin air, but these stories were often dismissed as exaggerations or the product of a seafarer's imagination. The Draupner event changed all that. It provided the first concrete evidence that rogue waves were not just the stuff of sea tales, but a real and present danger in our oceans. This event marked a turning point in our understanding of the ocean and its powerful forces. It was the catalyst for a wave of research into understanding these sea giants better. Since the Draupner wave, scientists have been working tirelessly to unravel the mysteries of rogue waves. The more we understand about these waves, the better we can prepare for their impacts. But as we will see, there is still much to learn about these fascinating and powerful phenomena. This event marked the beginning of intensive research into these extreme waves. Until recently, scientists believed that rogue waves were formed by the nonlinear interaction of waves in the ocean. This theory suggested that rogue waves were a statistical anomaly, a rare convergence of ordinarily behaved waves into a formidable giant. But an expedition to the Southern Ocean in 2017 would challenge this understanding. In a region known for its tempestuous winds and towering waves, a team of scientists set out to capture the elusive nature of rogue waves. Armed with advanced stereo cameras aboard the South African icebreaker, SA Agulhas II, they braved the icy waters of Antarctica to study the behavior of these oceanic titans. The cameras offered a new perspective, not just recording the height of the waves, but also capturing their movement and interaction. It was here, amidst the swirling chaos of the Southern Ocean, that they found something unexpected. In an environment where multiple waves overlapped, creating a turbulent seascape, and where the winds howled unceasingly, the waves didn't just randomly converge. They grew progressively taller, longer, and faster. It was a stunning revelation. The wind, it seemed, played a more significant role in the formation of rogue waves than previously thought. The data showed that these giant waves were particularly sensitive during their young phase, the early stage of their formation. It was during this phase that the wind could whip them into monstrous proportions, giving birth to rogue waves. This was a groundbreaking discovery that challenged previous theories about rogue wave formation. It painted a new picture of these oceanic giants, not as statistical outliers, but as the products of a dynamic interaction between wind and sea. And it suggested that with an understanding of wind patterns and sea surface measurements, we might be able to predict the occurrence of these rogue waves, a significant step forward in ensuring maritime safety and protecting coastal infrastructure. This discovery was a testament to the power of scientific curiosity and the relentless pursuit of knowledge. The discovery that wind can influence the formation of rogue waves was significant for several reasons. For starters, this research has challenged our previous understanding of these oceanic behemoths. The long-held belief that rogue waves were merely the product of a random statistical convergence of waves has been thrown overboard. Instead, it has become clear that the ocean's breath, the wind, plays a pivotal role in their creation. In the tumultuous seas of the Southern Ocean, scientists observed something fascinating. When multiple waves overlapped and wind conditions remained constant, these waves did not simply bob along. No, they transformed, growing taller, longer, and faster. They evolved into rogue waves, but the significance of this discovery extends beyond simply understanding how these waves form. It gives us a chance to predict when they might occur. By observing wind patterns and sea surface measurements, we could potentially forecast the emergence of rogue waves. This is a game changer. Imagine the implications for navigation safety. The ability to anticipate these waves could greatly enhance the safety of seafarers. Ships could reroute or take precautions to avoid these maritime monsters, reducing the risk of disaster at sea. Moreover, there's potential to protect maritime structures. Offshore platforms, wind farms, and coastal infrastructure could all benefit from these predictions. By knowing when a rogue wave might strike, we can prepare for the impact and potentially mitigate the damage these waves can cause. The discovery also opens up intriguing new avenues for research. Could we find ways to suppress the formation of rogue waves? Or perhaps develop wave energy technologies that harness their immense power? The possibilities are as vast as the ocean itself. These findings not only solved a long-standing mystery, but they also opened the door to new methods for predicting and potentially mitigating the dangers of rogue waves. So, while the ocean may still hold many secrets, we are one step closer to understanding its unpredictable nature.